Next chapter, the three-dimensional geometry. Geometric properties of solids. Now, solids are made from plane figures folded or joined together to produce a 3D orientation. The flat surfaces of a solid are called faces, and these are made from plane figures. This figure has 6 faces. All are equal, and the figure is called a cube. The line segments where 2 faces meet are called edges. This cube has 12 edges. Vertices are points where 2 or more edges meet. A cube has 8 vertices. A cuboid has 6 faces, 12 edges, and 8 vertices as well. A triangular prism has 5 faces, a top and a bottom triangle, and 3 rectangular faces. It has 9 edges and 6 vertices. While plane figures with straight edges are called polygons, solids with flat faces are called polyhedrons or polyhedra. When drawing 3-dimensional solids on a flat surface, the edges that are visible from the angle of view are drawn in continuous lines. The invisible edges are drawn in broken lines. In this cube, these edges are visible from this angle, and so the lines are continuous. Those behind are invisible and are therefore drawn in broken lines. The cuboid is similar to a cube, except that it has rectangular faces. A triangular prism will be drawn as shown on your screen. Planes. A plane is a flat 2-dimensional surface that extends indefinitely. When 2 planes intersect each other, the intersection is a straight line. The angle formed by 2 intersecting planes is equal to the angle formed by 2 lines drawn on each of the planes. Next, projection of a line on a plane. A straight line is a 1-dimensional element connecting 2 points by the shortest distance, and the length is always a true length. The projection of a line can be obtained by drawing the projections of its endpoints on a flat plane. In this diagram, we have a vertical plane VP and a horizontal plane HP. Consider a straight line AB perpendicular to HP and parallel to VP, where point A is H units above HP and point B is D units in front of VP. If light is shone directly in front of the line, you can observe the shadow of the line as A'B' on the plane VP. This is called the projection of the line AB. If you look straight on top at point B, it appears to hide point A. So the projection of point B passes through A to meet HP at point C, which is the top view. Consider another case. A line AB is inclined to HP at an angle theta and parallel to VP at a distance of D units. Point A is H1 units above HP and point B is H2 units above HP. The projection of line AB onto VP and HP is the line A'B' as the front view and the line AB as the top view, respectively. Consider line AB parallel to VP and inclined to HP by an angle of 45 degrees. Its projection A'B' on VP gives its true length and an inclination with XY. The top projection is a shorter line AB1 parallel to XY. Reversing the case, the line is parallel to HP and inclined to VP by 30 degrees. Observe that the projection AB2 is the top view and makes an angle of 30 degrees. Since the line is now parallel to HP, its front view is the line A'B'2 parallel to XY. The angle between a line and a plane is the angle between the line and its projection on the plane. Next, skew lines. Now, any two lines in a plane are either parallel or intersecting. If the two lines are parallel, then the shortest distance between them is the perpendicular distance between them. If the two lines are intersecting, then the shortest distance between them is 0. Equally in space, the shortest distance between two parallel lines is the perpendicular distance between them, and the shortest distance between intersecting lines is 0. However, in space, there are lines which are neither parallel nor intersecting. Such lines are called skew lines. Skew lines always belong to different planes, and so they are also called non-coplanar lines. Although skew lines never intersect, they form an angle between them, since they are not parallel. To find the angle formed by skew lines, one of the lines must be translated. We do this by projecting one of the lines onto the plane containing the other line. For instance, the projection of line 1 onto the blue plane will form an intersection with line 2. The angle can then be measured. For example, in this figure, lines FB and EH are skew. To find the angle between them, we translate any of them. If we project FB onto the plane CDEH, it will be mapped onto EC. And so we have a right-angled triangle. And you can see that if you remove the rest of the figure. Using trigonometric ratios, tan x is equal to 5 over 10, and that is 0.5. Tan inverse of 0.5 is 26.6 degrees. We take an example. Now, in this cuboid, given the measurements, AB is 3 centimeters, BF is 2 centimeters, and BC is 7 centimeters, we want to find the lengths EG and AG, and also the angles AGE and AGF. Now, before we start, it is important to appreciate that in a cuboid, all the edges intersect at 90 degrees. It also means that whenever the faces meet, they do so at 90 degrees. To work out such a question, it is important to try and imagine the shape carrying the required side or angle being in isolation. Let's see what we mean by that. First, the length EG. If you look at EG, you will see that it's the diagonal of the bottom rectangle. And being a rectangle, it means the angle at F, that is EFG, is 90 degrees. So you might want to think of line EG as the hypotenuse of the triangle EFG. I have drawn it in black so that we can see it. We put those measurements. And if you remove the rest of the figure, we remain with the triangle, and that makes it easier to work out the sides. Using Pythagoras' theorem, EG squared is equal to 3 squared plus 7 squared. To find EG, you are going to have to find the square root on both sides. And you shall get EG is equal to 7.62 centimeters. Next is length AG. Now AG is a line in space. It doesn't lie on any of the 6 rectangular faces. But you can think of AG as forming part of a triangle AEG. Again, all the 4 planes on the sides are perpendicular to the bottom plane. It therefore means that the line AE is also perpendicular to the bottom plane. Therefore, triangle AEG is right angled at E. If you remove the rest of the figure, you will clearly see the triangle. And so AG is the hypotenuse. Using Pythagoras' theorem, AG squared is equal to 7.62 squared plus 2 squared, and AG is equal to 7.87 centimeters. Now we don't even need to go back to the whole figure so that we can find angle AGE. Using trigonometric ratios, tan AGE is equal to 2 over 7.62, opposite over adjacent. That gives us 0.2625. Tan inverse of that is 14.7 degrees. Finally, angle AGF. This looks a bit tricky, but if you look at it clearly, line EF and GF are perpendicular. It means therefore that plane ABFE with the green line is perpendicular to the line GF, and so any line on that plane is perpendicular to the line GF. And therefore AGF is a right angled triangle. If we isolate it, this is it. Now we can find the angle AGF. Cos AGF is equal to 7 over 7.87. That gives us 0.889. Cos inverse of that is 27.25 degrees.
It applies course to course, it applies class to class. Miss a class, one class, maybe that's fine. Miss 2 or 3 for whatever reason, the rest of they're speaking a foreign language for you, and you just have to make it up, or going to class has no point. If you don't go to class, it just gets worse. It snowballs, and once it starts going downhill, you're in trouble. And so the biggest secret, or the biggest piece of advice is get help early from as many people, and there's lots of sources for help, that other students in the course, teachers, etc. And so go there for it, and go early, and go as often as necessary.